On Drop7 as well, we get updates on how to create particles for fluids. We have a new Drop7 liquid solver, an SPH liquid solver. It gets updated, and we have a new way to create forces for liquids. So we will see all of that. The first one is the water level. It's a way to create easily particles based on a right intersect. So basically, here I select my emitter. This is a square. You select your ground objects. That is my ground. And that's all. Basically, you define where you want to detect the stuff. So basically, it's creating a right intersect, and it will only create particles where it's needed, as you can see. It rasterizes the space. It's pretty cool because if now we want to do a lake, let's say it there. Before it was kind of complex. We should create some kind of create this space and create a volume, and it's kind of tedious. But now we have this space exactly fill. If you need to fill cups, glasses, or any space, it's very easy. You can define multiple stuff. The most important maybe it's a grid size. So basically it's how you rasterize this space. You have variation. If you want, normally if you do a liquid you want at 0, but you can offset these positions. You can define only when a material ID is detected, and you send it to this group object, and that's all. You can show you have mode generate or only test. Test, it only creates a line. It's difficult to see now. It creates lines. So if you work with a lot of particles, it's good to have it as a test because it's not creating any particle, only to see what you are doing. And then when you want to create particles, you go to generate, and here you have it. And then it stops showing. So we have this. Then let's see our flow. On our group, we have SPH 6.6 was the old one. Let's see what it's doing. 6.6, the SPH always was not keeping very well velocities. As you can see, it's kind of a stable 6.6, not very explosive. And now we will go to 6.7. And you will see that now it's trying to calculate from the first frame. You will see that it's much more explosive. It's trying to keep much more velocities from pressure and all this stuff. And you will see more particles going crazy. That's kind of cool. It's funny because now that I am recording, this is going way slower than before. But yeah, you can see here the particles, a splash. It's creating a splash, really. So yeah, way more explosive. And on this 6.7, more cool stuff, not only 6.7, but in general, is that we have different ways to show density, and you have a RAM, so it's much easier to see what's going on there. You have min and max info. You can check density change, a lot of stuff. And one cool thing is the white water, and maybe it's not straightforward. White water, what we'll do is to create data channels with color information, and it tries to create white water. That is basically when water gets mixed with air, it creates this white foam. And the cool thing is that after some time it will get back to water. So it detects when there is a change of density, it will change to white, and over time it will go back to blue in this case. But what do you need to do? You need to have data channels, because that's also new on this version. You can transfer some of this information to a data channel to manipulate it later. So in your fluids, you need to have a data channel that we will call it white water. Let's add it. It's data channel 0. Now on our group, we will say that our white water will be data channel 0, and now it will display this white water. So all these particles here should be blue now. White, sorry. So as you can see, it's working. Let's see what it's doing. When it explodes, it gets mixed with air and it becomes white. And after a certain time that is defined here by the density change is in which time they will become white based on density change. And you have fade out frames. So fade in is like immediately when this density change happens, it gives a value of 0, and over 2 seconds it will go back to blue, and you will see that the white particles automatically fades away at blue. And it's pretty cool. It gets mixed with water. If you need to do rivers or all this stuff, it's a very straightforward thing to do it. Jump back to 6.6 basically because it's not so explosive, and for the example I try to do, it's easier. And we will see Mesh Force. Mesh Force, you select your groups and you select a force that will be an object. In this case is this object there. And it's animated with a wave from left to right. Basically each particle is doing a right cast, so it's checking on this object Z. And I am setting this as a force. You can set it as a velocity. And you can say if you want that this is a pressure, it's move, it's a lift, it's normal constraint, pressure constraint. It gives kind of different looks to your liquid. And you can have attenuation and you can have all this kind of stuff. And you can show it. So let's see what's going on. This is moving slowly, and as you can see, since I am showing the force zoom, let's add this at 2 so you will see it better. Now I am recalculating every frame. You can see here that it's adding this pressure to these liquids, and it will create a wave. As you can see, liquid that's moving right to left. Maybe from far away will be easier to see. Let's add more time range. So liquids, it's moving from right to left. So it's a very easy way to create wave, to create all types of forces. It's pretty cool actually. You can see this wave, and it's a very simple movement. And so this force, you can control it with intensity by here. Let me turn off edit on the fly. So now if I go to intensity 3, you see that I am adding much more force there, and now it will go crazy. Now it's really jumping, basically, so you can visualize what's going on. It's adding this crazy force to the liquid. Pretty cool for very fast test. And you can play with a lot of things. So you can do we check the pressure, you can do the lift, that it's pushing up a little the particles, move. Everything is doing different things with this intensity, but as well you can play with tangential, parallel, or directional forces based on this. Let's say that we want the parallel to 50, and you can see what type of force it's creating. Parallel will create this type of force. Tangential is tangential to the face. Let's create, and you can mix up this, so you can have parallel 50, tangential 20, so it will push a little up or not, whatever you want. So now you will get here with this some circulation of the water. I hope you can see it. Maybe it's easier now, instead of showing white water, let's change density, or let's change velocity change. Velocity change will be good, I guess. Yeah, this will make it easy to see what's going on. So I push it quite far, but particles are moving in circles based on this mesh. So you can animate the mesh, you can do very cool stuff with this. And as you can see, it's quite fast, even if I am recording that. Without recording, this is twice as fast as this. But yeah, very easy to create all kind of weird motions now with this mesh force.